Your brain is not the problem. You are just not using the appropriate methods to solve questions. My name is Green and you are welcome to Tuteria. Today we'll be looking at a problem in its capacity, a very simple question that you can actually solve without calculating anything here. If the heat capacity of a 100 gram of a substance is 3000 joules per Kelvin, what will be the heat capacity of 10 kilogram of the substance? So that means that the concept is about heat capacity. What is heat capacity? It is the amount of heat required to change the temperature of a substance. Heat capacity is an extensive quantity, meaning that it actually depends on the amount of that matter that you are considering. What does this whole thing imply? Now, heat capacity can be calculated using two different methods. Heat capacity, which is denoted by this capital C, is actually the quantity of heat required per the change in temperature. From the definition, the amount of heat required to change the temperature of a substance. So from that definition, it is C equals quantity of heat Q divided by the change in temperature. However, heat capacity can also be determined using this simple formula as well. Heat capacity C, which is also called thermal capacity, is equal to the mass of the substance times the specific heat capacity of that substance, small c. Now, how do I solve this problem? Which of the two formulas will I use? Which of the two methods will I use? The method you will use is dependent on what we have in the problem. What are the things that are being asked in this question? So the concept is about the mass, the heat capacity of 100 grams of a substance. So the mass is this. So we are given the heat capacity and the mass. Now, when the mass now changed to 10 grams, what will be the heat capacity? From the problem here, it is so clear that the question is about relationship between heat capacity and mass. So that implies that this first formula should not be used. Just understand what the question is all about. Heat capacity and mass. There is nothing about mass in this problem, in this question here. So we are left with just this. C equals to MC. What is this C here? Specific heat capacity of a substance, which is an intensive property. It does not change with mass. For instance, the specific heat capacity of 2 grams of water is 4186 joules per kilogram per Kelvin. The specific capacity of 100 grams of water is still the same value. That implies that in this formula here, this small c is a constant. That means that we can simply say that our heat capacity C is just directly proportional to the mass. That means that there are some problems in physics that it is just your knowledge of variation that you need. Heat capacity C is actually directly proportional to the mass because the specific heat capacity is a constant. It does not change with the amount of matter we are considering. So this is just pure variation. So what is happening? This is a direct relationship, and in direct relationship, it means that if this guy is going up by an amount, this guy should also go up by that same amount. If mass increases by 2, then the heat capacity should also increase by 2. If the mass is going down by 10, then the heat capacity should also go down by 10. That is how direct variation works. So let's look at that problem. What is happening? The mass changed from what to what? From 100 grams of the substance to 10. 100 to 10. That means the mass is going down by 10. So if the mass is going down by 10, it simply means that the heat capacity should also go down by that same 10. So that means that if the heat capacity should go down by 10, it should move from 3000 joules per Kelvin to what now? 300 joules per Kelvin. Just divide by 10 here. That means that the new heat capacity for this problem will be 300 joules per Kelvin without even solving. Your knowledge of variation is more than enough for this type of problem. Just understand the question, and from your understanding of the question, use the appropriate method, and that's all. We've been able to see here that at the end of the day, it is not just about formulas in physics alone. You just need to understand the concept. We can have multiple formulas for a particular problem, for a particular quantity, what you need to use at the end of the day is dependent or relies on what you are given on the problem. So it is how you understand the problem, you break it down, that will now determine what you use to solve that problem. I am Green once again. See you next time.